Space is already the universe's freezer. The cosmic microwave background, the leftover heat from the Big Bang, sits at minus 270 degrees Celsius. That's cold enough to freeze anything solid in seconds. But there's a place that makes space feel warm. A cloud of gas 5,000 light-years away that's so cold, it absorbs the background radiation of the universe itself. 1 Kelvin, minus 272 degrees, less than half a degree above absolute zero, the temperature where atoms stop moving entirely. It's called the Boomerang Nebula, and the reason it exists is even stranger than the cold. In 1980, two Australian astronomers, Keith Taylor and Mike Scarrett, were surveying the southern sky from the Siding Spring Observatory. They found something peculiar, an object in the constellation Centaurus with a strange, lopsided shape. They named it the Boomerang Nebula because through their telescope, it looked bent, like a boomerang frozen mid-flight. For 15 years, it was just another nebula in the catalog, a curiosity, nothing more. Then, in 1995, a team pointed the Swedish ESO submillimeter telescope at it, and what they found didn't make sense. The nebula wasn't emitting heat. It was absorbing the cosmic microwave background. The faint afterglow of the Big Bang, which fills all of space at 2.725 Kelvin, was being sucked into this cloud. That meant one thing. The Boomerang Nebula was colder than space itself. 1 Kelvin. Let that sink in for a second. On Earth, the coldest temperature ever recorded naturally was minus 89 degrees Celsius in Antarctica. That's 184 Kelvin. Mars averages minus 63 Celsius, about 210 Kelvin. The dark side of the moon drops to minus 173 Celsius, still 100 Kelvin. Space itself, the empty void between galaxies, sits at 2.725 Kelvin thanks to the Big Bang's leftover heat. Everything in the universe is bathed in this background warmth. It's the floor, the baseline. Nothing should be colder, except the Boomerang Nebula. At 1 Kelvin, and in some regions, ALMA measurements in 2017 found it's actually less than half a Kelvin. The molecules in this cloud are barely moving. Carbon monoxide gas, dust grains. Everything is within a single degree of absolute zero, the point where all atomic motion ceases. To give you a sense of scale, the ultra-cold gas cloud surrounding the Boomerang Nebula stretches across 120,000 astronomical units. That's 120,000 times the distance between Earth and the Sun. This frozen cloud is about 30 times wider than Phoenix A, the largest black hole in the known universe. An entire supermassive black hole, the biggest thing we've ever measured, would fit inside this cloud of near absolute zero gas. 30 times. So how does a cloud of gas get colder than the universe itself? The answer is violent. The Boomerang Nebula is a pre-planetary nebula. That means it's a dying star in its final act. The central star, once a red giant, is shedding its outer layers. But this isn't a gentle leak. This star is losing mass at a rate about 10 times faster than similar dying stars. Gas is blasting outward at 164 kilometers per second. That's 590,000 kilometers per hour. Fast enough to cross the continental United States in under 30 seconds. As that gas explodes outward into the vacuum of space, it expands rapidly. And rapid expansion means rapid cooling. This is adiabatic cooling, the same principle that makes a can of compressed air feel cold when you spray it, scaled up to cosmic proportions. Imagine taking the coldest thing you've ever felt, multiplying that sensation by 1,000 and spreading it across a region of space 120,000 times wider than Earth's orbit. That's what's happening inside the Boomerang Nebula. But here's what makes this even stranger. A single dying star shouldn't be able to produce outflows this fast. The speeds are about 10 times higher than what a lone red giant can manage. So in 2017, a team led by Raghavendra Sahai at NASA's Jet Propulsion Laboratory proposed an answer, one that changes how we understand the Boomerang Nebula entirely. The central star wasn't always alone. It had a companion, a smaller star, orbiting close. And as the primary star entered its red giant phase and began to swell, that companion's orbit decayed. It spiraled inward, and eventually, it plunged into the heart of the red giant. The gravitational energy released by two stars merging is enormous. That energy blasted most of the red giant's envelope into space, the ultra-cold outflow we see today. The numbers back this up. ALMA measurements show the outflow has been happening for somewhere between 1,050 and 1,925 years. On a cosmic timescale, we're watching the immediate aftermath of a stellar collision. The coldest place in the universe exists because one star ate another. There's one more puzzle: the shape. Hubble images show a classic hourglass, twin lobes with a narrow waist. It's beautiful. It's symmetrical. It looks exactly like what you'd expect from a dying star. But ALMA, observing in millimeter wavelengths where cold gas glows bright, saw something completely different. The outer cloud isn't an hourglass at all. It's roughly spherical, an elongated, nearly round bubble of freezing gas. The hourglass shape we see in visible light is an illusion. Here's what's happening. A dense ring of millimeter-sized dust grains surrounds the central star. This dust ring acts like a mask, blocking the star's light in the equatorial plane. The only light that escapes shoots out through the poles, illuminating two narrow cones of the surrounding gas cloud. Those two illuminated cones are the bow tie we see from Earth. The rest of the cloud, nearly spherical, stretching vastly farther than the hourglass, is invisible in optical light. It's there. It's freezing. It's expanding. But until ALMA looked at it, we couldn't see it. The Boomerang Nebula has been hiding most of itself from us for 35 years. This record-breaking cold won't last. The central star is evolving. As it continues its death sequence, it will contract and heat up. Its core, currently not hot enough to produce significant ultraviolet radiation, will eventually reach temperatures that ionize the surrounding gas. The nebula will begin to glow. It will warm. Astronomers estimate we're catching the Boomerang Nebula in an incredibly short-lived phase. 1,000 years, maybe 2,000. In cosmic terms, that's a camera flash, the blink of an eye. We happen to build telescopes at exactly the right moment to witness it. Lars-Åke Nyman, an astronomer at the Joint ALMA Observatory, put it this way: "We see this remarkable object at a very special, very short-lived period of its life. It's possible these supercosmic freezers are quite common in the universe, but they can only maintain such extreme temperatures for a relatively short time. There could be hundreds of these ultra-cold nebulae out there, thousands. We just can't see them, or we missed them, or we haven't built the right instruments yet." The Boomerang Nebula isn't just a record holder. It's a window into a phase of stellar death we barely understand. Here's what gets me. We think of stars dying as a hot process, supernovae that outshine galaxies, nuclear furnaces burning for billions of years, heat and light and violence. But the Boomerang Nebula is the opposite. A star's death, frozen in place. a cloud so cold that even the faint warmth of the Big Bang, a glow that's been cooling for 13.8 billion years, is too hot by comparison. And it exists because of a collision. Two stars orbiting each other for millions of years, until one swelled and swallowed the other. That act of destruction created the coldest natural place we've ever found. The universe doesn't just destroy with fire, it destroys with ice. So it's not that dying stars always burn out in a blaze. It's that some of them freeze the universe around them on their way to becoming something new. Follow for more mind-blowing space facts.